Welcome to Z. Today, we're venturing into the fascinating intersection of artificial intelligence and astronomy. As our quest to understand the universe intensifies, AI emerges as a powerful tool, revolutionizing how we collect, analyze, and interpret astronomical data. From identifying distant galaxies to predicting cosmic events, AI is reshaping the landscape of astronomical research. Join me as we explore the myriad ways artificial intelligence is unlocking the secrets of the cosmos. To appreciate the role of AI in astronomy, we first need to understand the challenges astronomers face. The sheer volume of data generated by modern telescopes is staggering. For instance, the Large Synoptic Survey Telescope, LSST, is expected to produce approximately 15 terabytes of data every night. This data overload can be overwhelming for human researchers. Traditional methods of analysis are often too slow or insufficient to extract meaningful insights from such vast datasets. This is where AI steps in, providing powerful algorithms and techniques to handle, analyze, and interpret data more efficiently. One of the primary applications of AI in astronomy is data analysis and image processing. Advanced machine learning algorithms can analyze images from telescopes, identifying patterns and features that may not be easily discernible to the human eye. Galaxy classification. AI is particularly useful in classifying galaxies. By training algorithms on existing databases, researchers can create models that automatically categorize galaxies based on their shapes, sizes, and features. This process, which once required countless hours of manual analysis, can now be accomplished in a fraction of the time. Transient event detection. AI can also be employed to detect transient events, such as supernovae or gamma-ray bursts. By analyzing time series data from telescopes, machine learning algorithms can identify changes in brightness that signify these cosmic phenomena, alerting astronomers for follow-up observations. Noise reduction. Telescopic images often contain noise from various sources, including atmospheric interference and instrumental artifacts. AI algorithms can effectively filter out this noise, enhancing the clarity and quality of astronomical images, making it easier to study celestial objects. Beyond data analysis, AI plays a significant role in simulations and modeling in astronomy. These simulations help researchers understand complex cosmic phenomena and predict future events. Cosmological simulations. AI can optimize simulations of cosmic evolution, allowing scientists to model the formation of galaxies and clusters. By analyzing the outcomes of different initial conditions, researchers can refine their understanding of how structures in the universe evolve over time. Exoplanet discovery. The search for exoplanets has been greatly enhanced by AI. Machine learning algorithms can analyze data from space telescopes like Kepler and TESS, identifying potential exoplanets by detecting periodic dips in brightness caused by transiting planets. This accelerates the discovery process and increases the chances of finding habitable worlds. Astrophysical processes. AI can also assist in modeling astrophysical processes, such as star formation and the dynamics of black holes. By training models on observational data, researchers can gain insights into the underlying physics that govern these phenomena. Data mining and pattern recognition are additional areas where AI shines in astronomical research. The vast datasets generated by surveys and archives contain a wealth of information waiting to be uncovered. Anomaly detection. AI algorithms can sift through extensive datasets to identify anomalies that may indicate new phenomena. For example, unusual light curves may suggest a previously unknown type of celestial object or event, prompting further investigation. Pattern recognition. Machine learning techniques can also be employed to recognize patterns in large datasets, such as identifying correlations between different astronomical phenomena. This capability can lead to new discoveries and deepen our understanding of cosmic relationships. Citizen science. AI is increasingly being integrated into citizen science projects, allowing amateur astronomers and enthusiasts to participate in data analysis. Platforms like Galaxy Zoo use AI to assist volunteers in classifying galaxies, combining human intuition with machine efficiency. The application of AI extends beyond Earth-based research. It's also playing a pivotal role in space missions. Autonomous navigation. Spacecraft, like the Mars rovers, utilize AI for autonomous navigation. These systems enable rovers to make real-time decisions about their paths, optimizing their exploration of the Martian landscape without waiting for instructions from Earth. Data collection. AI can optimize the data collection process in space missions. For instance, AI systems can prioritize which observations to make based on real-time analysis, ensuring that the most significant events or phenomena are captured. Interplanetary communication. AI algorithms can enhance communication protocols between spacecraft and Earth, improving the efficiency of data transmission and reducing the time needed for decisions during missions. While AI offers exciting possibilities, it also raises important ethical considerations and challenges. Bias and transparency. AI algorithms can inadvertently inherit biases from the datasets used to train them. Ensuring that AI systems are transparent and unbiased is crucial, particularly in scientific research, where integrity is paramount. Data privacy. As astronomical data increasingly incorporates AI, concerns about data privacy and security arise. Researchers must be vigilant in protecting sensitive information and ensuring that data is used ethically. Collaboration and training. The integration of AI in astronomy requires collaboration between astronomers and computer scientists. Training researchers to effectively use AI tools is essential for maximizing their potential while minimizing pitfalls. Looking ahead, the future of AI in astronomical research is bright and full of potential. As technology advances, we can expect even more sophisticated applications and innovations. Improved algorithms. Ongoing research will continue to refine AI algorithms, making them more effective in analyzing complex astronomical data. As computational power increases, the ability to process and interpret data will expand exponentially. Collaborative efforts. The collaboration between astrophysicists and AI experts will lead to groundbreaking advancements. By working together, these fields can create new tools and methodologies that will propel astronomical research into uncharted territory. Interdisciplinary research. The integration of AI into astronomy will foster interdisciplinary research, bringing together experts from various fields to tackle complex problems. This collaborative approach will enhance our understanding of the universe. Artificial intelligence is transforming the field of astronomy, providing powerful tools that enhance our ability to explore and understand the cosmos. From data analysis and image processing to simulations and space missions, AI is unlocking the secrets of the universe in ways we never thought possible. As we continue to harness the power of AI, we are not just advancing our scientific knowledge, but also deepening our connection to the cosmos. Thank you for joining me on this journey through the role of artificial intelligence in astronomical research. Until next time, keep your eyes on the stars and your curiosity alive.